This is a man-made lake in eastern France that has been dammed to make a power station. Water falls a staggering 1,000 metres to the Gran'maison power station, which is situated below. Water in the top reservoir is released by valves into the power station below, where it generates electricity. It is then released into a lake. Because the power station can respond almost instantaneously to increased demands from the grid, it is a very useful facility. The power station can be switched off almost instantaneously, and this makes excellent use of this free source of energy. During the night, the power station can use electricity generated by nuclear plants and pump the water back up the hill into the top reservoir. By pumping the water back uphill, it means the water can be used to produce energy at least 6 times. This river, flowing through the pretty market town of Pontcharra, originated high up in the mountains that feed the lake for the Gran'maison. This river had already given up some of its energy to a small hydroelectric power station before it flowed through the town. Though the market is taking place, the inhabitants are outside and not using very much electricity, but at different times of the day the inhabitants can make great demands on the national grid system, just as happens in this country. Coal and nuclear power stations are very good at supplying a constant rate of electricity, but very bad at coping with sudden high demand. France, being a mountainous country, means that there can be lots of hydroelectric stations, and indeed France generates 20% of its electricity from water, which is of course free and green. The town of Vesoul, which gave birth to the French Revolution, is downstream from the Gran'maison power station. Water flowing through this town has probably come from the Gran'maison power station. These people from the Gran'maison Twinning Association are hungry, having visited the power station, and are eagerly anticipating their lunch. A post-stroll lunch seemed to be called for, and indeed much needed. This hydroelectric power station, like the one at Pontcharra, is unable to store its water. It also means that the water tumbling down the side of the mountain cannot be used to generate electricity. The water flows down the valley and joins the river Isère, which eventually flows into the Rhône. There had to be a better solution than this one of 500 small hydroelectric plants. These parapentists, or hang glider enthusiasts as they are called in France, are converting the potential energy that they have gained by going up the mountain into kinetic energy so that they can fly down the valley. Unlike the diesel engine bus that provided the potential energy for these people, the sun provides the potential energy for the water that gathers at the top of the mountains in the streams. The mountains round the lake that feeds the power station Gran'maison concentrate all the small streams so that they can keep filling the lake. The top lake is 1,700 meters above sea level. The lake contains 137 billion liters of water. The dam is 140 metres high and 560 metres long. The dam took several years to build and the materials were quarried locally. The outside of the power station is unimpressive, especially as it is capable of generating nearly as much electricity as Didcot. Appearances are deceptive because the vast majority of the power station is beneath the ground. There is an all-pervasive hum produced by the electrical equipment. The upper generating hall seems to be empty, but this is because the generators are mounted vertically rather than horizontally, as in the case of Didcot. Water falls through a height of 1,000 metres and then hits the blades of buckets, which are called Pelton wheels. Each bucket is divided into two, so this increases the output of the generator. Like all power stations, there is heavy lifting equipment. The control room is the nerve centre of the power station. It is able to control the generators, but also the water that feeds the generators, as well as pumping the water back up to the top of the dam. There is a head of water of 1,000 metres, and this causes enormous pressures that have to be managed and safely dealt with. The control room staff have to be ready at all times to deal with the demands of the French grid. These massive pipes allow water to either come in or out of the lower power station. The engineering is massive and very impressive. These valves control which way the water goes. They also protect the equipment. This pump is just like the one in your washing machine, except much bigger. It also has a dual purpose in that water can either be fed into it to generate electricity, or it can pump the water back up. When it pumps the water back up, 3 of these pumps have to be in series to gain enough pressure because of the height of the upper lake being 1,000 metres uphill. We visited in the summer so we could see the machinery, which was in parts for maintenance, as well as some of the control equipment. Once generated, the electricity goes through different transformers and switchgear. Electricity leaves the power station on the French national grid, and who knows, it may even reach England through the link which runs under the English Channel. The level in the bottom lake is strictly controlled because it is used for recreation purposes in the summer.